right. Hello, everyone. Thank you all for coming to the last talk of today. Thank you all. I appreciate it. It's getting late, so first I'll try to keep some energy for you, so you can still listen. And today I'm here to talk to you about Agentic RAG systems using Langchain 4G, Ollama and Milvus. I am Stephen Batifol. I'm a developer advocate at Milvus. So if you have any questions, you can reach me directly on my socials. I'll be happy to answer you anything related to AI, vector database, Gen AI, LLMs, as I work in that field basically every day for the past year. Quick introduction, as I guess, who here is familiar with Milvus? I'm going to start here. Raise of hand. Okay, some people. Cool. For the others, we're part of the Linux Foundation, especially the AI data part. And yeah, we're an open source vector database. So, if you want to use a vector database for your Gen AI project, give us a look. We're very easy to start. So for Java-based applications, it's a Docker pool. And then you have everything running. We like to say that we're feature-rich, meaning that we support different kind of embeddings. We also support some metadata filtering, re-ranking, as I've seen in some previous talks as well before, and a lot of different features. We have integration with basically everyone you can think of in the whole AI world. Also, some fancy things. We've been elected as a leader in the vector database space, but you can have a look at this one if you want. And as I said before, we work a lot with the whole AI industry. So basically, we are connected with every framework you can think of. We also support a lot of different embedding models, different LLMs as well. We work with them directly. And then we have partnerships with NVIDIA and Intel to actually run some, for example, GPU vector search. So at one point, if you reach some insane scale, we're talking billion plus vectors, and then you want to have your results that are going to be very, very fast, then we support GPU vector search. And then the same for Intel. We also support some specific instructions for Intel CPU based. And if you're not familiar with the whole AI use cases and vector database, just some examples of the different use cases. So RAG is the one you already heard about it today. I guess in 4 or 5 talks. It means Retrieval-Augmented Generation. Also, the conference is for 5 days, so you're gonna probably hear about it about 35 times. So good luck for this one. But also you have recommender systems. They're a bit more old school, but they actually a lot of people use us for recommender systems. And then you can think of different similarity search. So text similarity search, audio, images. We're also working with some people creating proteins, actually using AI to create proteins. So they run molecular similarity search. And then we support multimodal as well, so meaning that you can search over multiple types of data. So think images, audio at the same time. And who is familiar with how vector databases work? Cool. Oh, actually a lot of people. Okay. So quick introduction. So why do we exist in the first place? So traditional database, was built upon exact search. So it was mostly keyword search, meaning that you're going to miss some context, some semantic meaning, or some user intent. So if you search for Apple, are you searching for the fruit, or are you searching for the company? If you search for change car tire, are you looking for how to change a car tire or when to change a car tire? So that's basically why we exist, is to actually address those and to help your users. Also, the world is just more than just text and keywords. So, some fancy numbers, but apparently, I don't know, some people can predict the future, but apparently 90% of the data in 2025 will be unstructured data. I don't know if that number is going to be true, but what I know is that actually a lot of data is unstructured. So then, if you're going to use a traditional database, you might not be able to use it. And, I talk to a lot of users, to a lot of people, and one of the questions they always ask is why not just, put a vector search libraries? There are different reasons. One is going to be about search quality. So, usually they don't support hybrid search or they don't support filtering. What about scalability? what if you have billions of vectors, or like tens of billions or hundreds of billions? How are you going to scale that point? What about the cost as well? Are you going to run everything in memory, or are you going to put something on the disk, or maybe on S3? And then, like different reasons basically, but that's why we exist. Like actually vector search in itself is very simple, but making it work at scale is where it's complicated. So yeah, we have Milvus. That's why we try to make it very easy to use. So first Docker pull if you are a Java-based user, and then you can use your different AI dev tools. We have SDKs for Python, Java, Go, and Node.js. So that's how you start it in Java. If you want to start it very easily, it's about 5 lines of code. And then you have Milvus running. And then, as I said before, our specialty is scale. So we have different offerings. If you're Python, we have what is called Milvus Lite. So, like I'm saying the forbidden word, but then you just like pip install PyMilvus. But then if you're not using Python, or even if you do, then we have Milvus standalone, which is just a Docker pool. And then once you go like crazy scale, we're talking hundreds of billions of vectors, then we have Milvus distributed, which is running on Kubernetes. And then it has everything to help you scale to like 100 billions. And yes, 100 billions, I mentioned a couple of times, is actually we have a customer that is running at this scale, so it's not just me talking about it. It's actually working with them to actually make it possible. It is very expensive, but for some people it's actually worth it. And otherwise, for the usual scale, we're talking about like 10 billions on a single instance. We also have like different index types. People already today from the talks I mentioned, they talked about DiskKNN, which is a different index. We support it. We support the classic HNSW and then, GPU index that I've mentioned in the past already. Also different search types. So if you have metadata filtering, sparse and dense search as well, multi-vector search, or different things. And just a quick intro so everyone can follow me after. But where do vectors come from, actually? I've probably mentioned it, I don't know, about 15 times already, the words vector, but where do they come from? You have to think that you have your documents, so what we call a knowledge base, and then those can be images, they can be audio, they can be text. You put them through a deep learning model, but what you're going to do is that instead of like predicting what it is, you're going to cut off at the last layer. So you put your data through the whole deep learning model, and then you just don't do the prediction. The last layer is usually the prediction. So that's why you're going to then cut it off before that. And why at the last one and not the first one is just because you want to learn everything that the model has learned. And what's very important is that you use the same type of model that has been, if you're going to search for data, for images, sorry, then you want to use a deep learning model that has been trained on images. Same for audio, and same for different type of data. So that's how you get the vectors, and then you store them directly in a database. And then they're basically called embedding models, and you can find them everywhere on the internet. I won't go into too much details, but have a look at Hugging Face if you're looking for some embedding models. Something to keep in mind is that, and I always say it's just because they're first on the leaderboard doesn't mean it's the best for your use case. So have a look at the different embedding models, have a look at what they're doing, and don't just go for the first one in the leaderboard. They're also like playing to optimize for it. So I am, for example, based in Germany. A lot of documents are in German. So then, some embeddings models will be better because they'll be trained on German. If I use some other ones, they usually are only in English. And how it looks like, basically looks like that. So, you're going to have your text, for example. You put it through your embedding models, and then you have your list of vectors. Then you project them in the vector space. And so then everything that is semantically similar is going to be in the same area in the vector space. And so then that's how we, we look for everything. And then we're going to look for the ones that are like semantically similar. So if you have, like, I don't know, some text about dogs, then they're going to be, similar in the vector space. Obviously, it's not in 3 dimensions. You have to imagine that it's way more, but it's a bit complicated to project otherwise. And how does it work exactly? It's just it's only similarity search. So, you have your unstructured data, and then you're going to transform it into some vectors, and then you have those embeddings. Then you store them into your vector database. And then on the other hand, your user is going to perform a query, which you're actually going to put through the same embedding models. So then you also get some vectors. And then you run a similarity search, basically. And then you usually don't do it on every point that you have in your vector space, because you might struggle to scale after like a couple of millions of vectors. But yes, you're running a similarity search, and then you get the results. And that's what we do. It's very easy to think. Like what's hard is actually to go at scale. And yes, as an overview, if you want, you basically have that. So you're gonna just search for the vectors that are very similar to yours. So, for example, for this request, which contain 1, 3, 6, 8, then the closest one are gonna be the first one, which is 1, 0, 3, and 5, and then 1, 4, 6, 7. 1, 4, 6, 9. Sorry. And then that's what you do basically for everything. I won't go into the details of the different indexes and how we do it, because it's mostly usually it's not very relevant during conferences. But yeah, RAG, the cool kid in 2023. Now we're still running the rave of the RAG, but we kind of moved on from the basic one. So just gonna give you a quick intro of the basic one, and then we'll move into Agentic RAG, and then I'll have a demo as well, where I can show you Agentic RAG in action. So we're going to use, browse the internet if it works, because the Wi-Fi is a bit spotty. And yeah, then we'll see. So the basic idea and why it's so popular is that you're going to force your LLM to work with your own data. And then you just do it by doing a similar semantic search similarity with a vector database, and then you give that to your LLM. That's the basic architecture. Just to give you some explanations, so you're going to have your data, and then you're going to extract the content. You're going to do some what we call chunking, which is basically dividing your data into different parts. And then you're going to put that through your embedding model, and then you have the vectors, so then you can store them directly into Milvus, for example. Then you have your user coming. Again, they have a query. They go through an embedding model, the same one, and then we do semantic search, and then we're going to find the similar data, and then we give that back as a context to the LLM. And then you have your response, and hopefully your user is happy. And why is it so popular? It's basically because LLMs can be out of date. They also usually don't have access to private knowledge, and RAG can help reducing hallucinations. So if you're going to talk with an LLM, they're getting better and better at that, but sometimes they can give you an answer that they think is correct, but it's just an hallucination. So RAG will help you reducing those, not removing them. And then you also have more transparency, so it can be easier, to understand what's going wrong in your pipeline. Against fine-tune can be expensive and it can be time-consuming, whereas RAG, you just plug and play, basically. And in Java, the basic RAG, it's basically like that if you use, so this one is just using Langchain, sorry. So you're going to load your documents, and then you create an assistant, and then you're going to say, okay, I'm going to use this language model, and then I have, my chat memory window, where I have I save different messages that I've exchanged, in the past. And then I have a content retriever, so I'm just going to go over all my documents, and then you have your conversation. So that's the basic one. And it's cool, but if you work in the search industry, you'll likely know this guy. But anyway, RAG is nice, but it's limited. It's basically only semantic search. So that's what I say, that's usually the naive RAG pipeline, so it's single shot, meaning that you have your query, you have your RAG, and then you give a response, but that's it. You don't have any query understanding, no planning. It's also not possible to use tools, and it has no reflection, no error correction. And also, it's fully stateless, meaning you don't really have a memory of what you talked in the past. It's always one question, one answer, and then we move on. Also, it can struggle to summarize different documents. or different questions. So, like you have to chunk everything, meaning that then if I ask my RAG, hey, can you summarize this document? Then it will actually, usually if you just go for the naive RAG, it will struggle to summarize because he only has access to like some chunks. And then he only retrieves the top 3 or top 5 or top 10 documents. And then it will be able to summarize those, but you might not be able to summarize the whole document. If your document is 300 pages long, likely your chunks, you're going to have like thousands and thousands of chunks. So then it will only summarize a subpart of the document. Also, it doesn't work for implicit data. What I mean by that is that if you ask, who is the company listed on the US stock markets with the highest valuation? If you don't have that in your data directly, then it won't be able to find it. That's something else where you have to compare the turnover of different companies, so that it can't do that. Also can struggle with multi-part questions. So if you ask, hey, what should I do in Antwerp? And then what's the turnover of, Lieferando or whatever, then it will struggle. It will be like very confused. And then it will tell you, maybe it will answer the first question, maybe it will answer the second, maybe it will be like, I have no idea what I have to do. So basically, it's necessary, but not sufficient. So now, here comes the new cool kid in town, Agentic RAG. And basically, it solves a lot of problems that you have with the basic one. So it's multi-turn, meaning that it's not only one question and one answer. It can also, it has query and task planning layers. You can also use some tools for your external environments. You can add some reflection and then memory for personalization. This last part is usually very useful. I don't know if you use Cursor, the new IDE, that is using with AI and everything. You're going to chat with it a lot. And then when you chat, you can maybe copy-paste some code, copy-paste some questions. You have to remember what has happened in the past, otherwise you're going to forget every time, and then it won't work. So yes, usually what we add is for self-reflection. We check the internet to actually verify what's happening. Then we add some query routing, so it's going to be whether to check or not our RAG system. And then we can also divide our query into subqueries, and then the memory, and then the different tools. So what I'm going to use, Langchain 4J, so it's a framework to build LLM applications, and it's focused on retrieving data and integrating with different LLMs. Also has integration with a lot of AI tools, so that makes my life easier. I'm also going to use Llama 3.2 with Ollama. So Llama 3.2, I use it because first it's open source and it's also multilingual, so that can be very handy. It's also very good at following instructions, summarizing things, prompt rewriting, and also using different tools. And Ollama, for the people that don't know, just allows me to basically run my LLMs locally on my laptop, and it's actually very easy. You just install it, and then you always pull the model, and then you can run them in any applications. And then, of course, I'm going to use Milvus. So I have a Docker image running on my laptop, and then you'll see I'm actually going to put the data directly into Milvus. Then we can see the data that is running. And for the internet, I'm going to use Tavilai. So I don't know if everyone's familiar with it, but it's basically a web search API, that is actually specialized for LLMs. So then it actually returns a format that is can be very useful for LLMs instead of just a markdown that is a scrap of a web page or something. So let's go. It's going to be demo time. Full disclaimer: I'm mostly a Python developer, but I wrote it in Java. So let's see. So I'm just going to show you the data that I have. Then I'm going to show you basic RAG examples, and then we'll go directly into the advanced one. So this is John Doe, which is a person that doesn't exist actually. It's usually used, in demos and stuff mostly. So yes, that's we have its early life, career beginnings. He's born in Fictionville in the USA, and then you can see, nothing exists about this person. Then we also have a different one, which is more actually something that is looks more like terms of use, sorry. So it's about, a rental car service, and then you have like different things, introduction, bookings, and stuff. So I have my Docker image running. Yes. So you can see I have Milvus running, and then we're using etcd for metadata, so we have that as well. But I'm going to zoom in a bit more. So I can just use directly my easy RAG example, which I'm going to show you the code, sorry. Forgot that part. Let me zoom out because it's quite big. So I'm just loading my documents, which are the one that I've shown you before. Those are the two documents that I've shown you, so the biography and then terms of use. And then I'm building, my AI service. Here, it's actually behind the scene. It's only Ollama that I'm using. So I'm like defining the URL, and then I'm saying, please use Llama 3.2. Then, yes, I'm still saying, please, I have this message window. We're going to have maximum 10 messages, and then we're going to create a content retriever. And then here, it's basically the same. You have, here I'm not using Milvus. I'm going to use it later. But here, it's just like in memory. You store everything in memory. And then I'm going to embed my text. And for the embedding models, I'm using mini-LM, sorry. That is a very simple embedding models, so just like here for the sake of the demo. So now it's actually running, so I can ask, I don't know who he is, John Doe, and then hopefully it should work. Yes. So, like that's the answer that you get once you go through the same path, like we did a similarity search, then we give that back to the LLM, and then we ask the LLM to actually generate the content. So then it's like, okay, according to the text, John Doe is an imaginary person, blah, 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 blah. LLMs love to talk. Llama 3.2 loves talking. So then sometimes, you have to like adjust those, especially if you're going to run something in production. You have to make sure, like maybe change your prompt to be like, hey, only give the answer, or maybe don't talk as much. And then I have another one. So you have to excuse me for my Java code quality, but it's going to be very similar. So this one, I'm creating my assistant. So again, I have my embedding models, which are the same one that I've used before. I can just show you quickly. So here we have mini-LM L6 again. And then instead of using the normal one, I'm actually going to use Milvus this time. So it's what I've shown directly on the demo before. So we build Milvus, and then it's running on the localhost because it's running directly in a Docker image. I will actually show you that I'm not lying, and then that I actually have 0 data on there. Actually, I am lying. So this is just a tool that we built. It's a UI to actually check our database. We can see that I have a collection. So what I'll do is that I will drop it. So you can see that now I'm not lying anymore. Now we have 0 collection. So what I'm going to do is actually, I'm going to transform all the data that I have. So it's going to go through the embedding model, and then we're going to store everything in Milvus, and then we can, run the query directly. So hopefully this one works. So we're going to be here. This one I can stop it. And this one, it's going to be a bit verbose. That's what Java loves, That's also what Milvus is doing. It talks a lot. But basically what it's doing in the back is just embedding all the text that I have, and then it stores it directly into Milvus. So you can see now I should have 1 collection. Yes. Now I have 1 collection. So I told you we just, like I just created it. So then we just inserted the data directly. And then if you want to see what it looks like, this is what it looks like. It's just, it's just created the chunks and then inserted those directly into Milvus. And then you have the text, which is like just a part of our documents before. And then we have the vectors, which are, just this list of float. And then, like, obviously, I'm not going to check them all because they're quite long, but then we can do our vector search directly. So yes, now my RAG is running. So I can still ask who is John Doe. And then, like now it embedded my question. And then now we can see, like this one is going to run the vector search directly into Milvus, but then it's also running Tabuli at the same time. So we have a vector search and a web search. And then we combine the two. We ask the LLM, hey, which one is the best, or which one is right, do you think? And then we can then have this one, which is apparently, there are two different ones. See, that's the demo effect, because I didn't have that before. And let's see if actually we get the same answer. But apparently there are some John Doe that exist, but I want them to actually not go on the internet, and I want them to actually check my data. But let's see. Yes. Now I have my fictional character. So that's, we can see. And then we actually can see then one of the problems that you can have when you use different sources is that, actually then someone exists with the name John Doe. So then you have to actually address those as well if you build your RAG systems. You're going to have a look and maybe ask your LLM, hey, which one is the best? Or then, you can do what we call metadata filtering, meaning that if I want you to only check in one part or about one person or one client, then, don't check for data that it belongs to like other clients or something. But yes, here we have, we can see that who is John Doe, and then we have the fictional character, so we're happy. But then we can also ask no, I crashed my demo. Then we can ask, questions about, for example, this conference. So when is it taking place or something, which is something that I don't have the data of. So when is taking place? And then this one will actually search into Milvus, but then it won't find anything. And then it's searching on the internet, and then it's going to find something. And then, yes, we have it here. So this one is coming directly from the web search, and then the LLM combined the two. And then we can see that, OK, it's taking place from October 7th to the 11th. And yes, then basically, if I want to show you something, I'm going to cheat a bit. I'm going to show you a Python code that I wrote. So you can see a way bigger workflow that I have. Just to show you, so this is what I built. So I'm going to ask a question. It's going to give the routing. Then it's going to retrieve my documents, grade my documents to check if they're actually answering the question. It's going to check if the documents are relevant or not. And then it's going to generate an answer, checks for hallucination. And then if we have hallucination, we go on, then we check again. And then we check if we answer the question. And then if we don't answer the question, we go on the internet and different things like that. Just for the sake of time, also, I'm just going to run everything quickly. So don't look, it's Python. It's not your language. But I couldn't just do like the whole thing again. But I'm just going to explain you quickly what I have. For example, for the router, this is usually how you work with LLMs. You're going to give them a prompt, and then usually you tell them, hey, you're an expert at. They usually like that. So then here you're like, OK, you're an expert at routing. Use a question to either a vector search or web search. And then I tell the LLM, hey, please, if you're going to use web search, return web search, and otherwise vector search, a vector store. And then we're like, OK, please only use that and everything. So you can have like an example. My data, just to tell you, is just like data on the internet, and it's about agents. So, it's like talking about agents and LLMs and everything. And then I'm just going to check, I'm checking here, like, for example, here, I'm like, this one, no, I'm going to go to my router. So then I ask the question, LLM agent memory, and then because I saw that into Milvus, then it goes into the vector store. And then I won't show you everything, but that's what it looks like at the end. I route my question. I check, if it's actually relevant. And then we generate our answers, check for hallucination, check if it's grounded, and then we give the results back. And so that's what you can have if you're gonna then build a whole agentic RAG. And my time is up, so I'm gonna take question. No, thank you very much. There's no question on this one. Thank you.